Deep inside this fortress of steel and precision, one of warfare's most powerful weapons takes shape.
From raw materials to battlefield power, witness the complete transformation.
It all begins with simple steel tubes, forged in fire and heat.
Hundreds of tons of raw material, waiting to be transformed into instruments of precision and power.
But before transformation begins, every piece must meet military-grade specifications.
The first step, precision cutting to exact specifications, measured in millimeters. Water jet cutters slice through hardened steel like paper, achieving tolerances that hand tools never could. Each cut must be perfect, as even a fraction of an inch could compromise the weapon's integrity.
Computer-controlled precision ensures every component matches engineering specifications exactly.
Automated systems move components with mechanical precision, maintaining the rhythm of production.
Every stage demands cleanliness, as debris could count catastrophic failure in the finished weapon. Multiple components are processed in parallel, each following its own path toward final assembly.
Human expertise validates what machines produce, a critical checkpoint in the chain of quality.
There are no second chances in military manufacturing. Imperfect components are immediately scrapped.
Approved components move forward, each tagged and tracked through every subsequent manufacturing stage.
Next comes the crucible of fire, where steel is transformed at temperatures exceeding 1200 degrees Celsius. Each tube must be heated uniformly, a process requiring both technology and human expertise.
As temperature rises, molecular structure changes, making the steel harder, stronger, more resilient.
Sophisticated sensors ensure precise temperature control, critical for achieving desired material properties.
Timing is everything. Remove too early or too late, the steel's properties will be compromised. Rapid cooling locks in the molecular structure, a violent transformation that gives the steel its final hardness.
In moments, the transformation is complete, and the steel now possesses the strength to withstand extreme pressures.
The quenched component must be inspected immediately for any warping or cracking that occurs during rapid cooling.
Tempering follows, a controlled reheating that reduces brittleness while maintaining hardness. Destructive testing of sample pieces validates that heat treatment achieved the exact metallurgical properties required. In the machining department, raw strength meets precision engineering. Each component is secured in computer-controlled lathes capable of precision measured in microns. Diamond-tipped tools carve the interior bore, creating the smooth barrel through which rockets will travel.
Layer by microscopic layer, the interior is refined to glass-smooth perfection.
Operators monitor every pass, ready to intervene if sensors detect any deviation from specifications.
Laser measurement systems verify that interior dimensions meet tolerances tighter than a human hair's width.
Threading is machined for connection points where components will join to form the complete launcher. Trigger mechanisms and firing assemblies require even greater precision, machined from solid blocks of aerospace-grade aluminum. Some assemblies demand the human touch, fingertip sensitivity that no machine can replicate. Every edge is deburred and smoothed, eliminating stress concentration points that could lead to failure.
Borescope cameras reveal what the naked eye cannot see, ensuring interior perfection.
Every component is documented, photographed, and logged into the tracking system before proceeding.
Wall thickness must be uniform. Too thin risks rupture. Too thick adds unnecessary weight.
Industrial cleaning removes all machining oils, metal particles, and contaminants before assembly. Dried and pristine, components are now ready for surface treatment and protective coatings.
Surface treatment is critical. These weapons must survive extreme conditions from Arctic cold to desert heat.
Sandblasting creates the perfect surface texture for coating adhesion, removing any oxidation or impurities.
Chemical phosphate treatment provides corrosion resistance and enhances paint adhesion. Multiple rinse cycles ensure no chemical residue remains to compromise the coating. Electrostatic powder coating provides military-grade durability, binding at the molecular level.
Electrostatically charged particles seek out every surface, creating perfectly uniform coverage even in complex geometries. Heat curing transforms powder into a rock-hard finish that can withstand impact, chemicals, and extreme temperatures.
At 200 degrees Celsius, the coating melts, flows, and bonds permanently to the metal substrate.
Cooling must be controlled to prevent coating stress. Patience yields perfection. Final coating inspection ensures no holidays, runs, or thin spots that could allow corrosion to begin.
In the assembly department, individual components become integrated weapon systems.
Each assembly begins with selecting quality-verified components that passed every inspection checkpoint. Trigger assemblies must be installed with precision alignment, ensuring reliable function under battlefield stress.
Thread-locking compounds and torque specifications prevent loosening during firing, where forces can exceed 100 Gs.
Optical sights must be aligned to within 1/10 of a degree, the difference between hit and miss at combat ranges.
Assembly line efficiency meets precision craftsmanship, each station adding complexity to the growing weapon system.
Support systems must deploy reliably every time, and soldiers' lives depend on equipment that functions flawlessly. Multiple weapon systems proceed through assembly simultaneously, a precisely orchestrated ballet of precision manufacturing.
Electrical firing systems require painstaking connection work. A single misplaced wire could mean catastrophic failure.
Before a single rocket is loaded, every electrical system undergoes comprehensive testing.
Each circuit is verified, each connection tested, eliminating any possibility of electrical failure in the field.
Safety mechanisms are tested exhaustively. Soldiers must trust their weapon won't fire accidentally.
Protective covers seal critical components against dust, moisture, and debris that could compromise function. Each weapon receives a unique serial number, creating permanent traceability from factory to battlefield.
Assembly complete, but the journey is far from over. The most critical tests still await.
In the testing facility, every launcher faces trials designed to exceed battlefield conditions.
Live fire testing reveals what simulations cannot, proving the weapon can withstand the violent forces of actual operation. High-speed cameras capture microsecond details, revealing how components perform under extreme stress. The moment of truth, rocket motor ignition generates forces that would destroy imperfectly manufactured components instantly. Environmental testing simulates Arctic cold, desert heat, tropical humidity, every condition soldiers might face. Vibration testing simulates transport in military vehicles over rough terrain, ensuring nothing loosens or fails.
Final inspection represents the culmination of hundreds of checks. The inspector's signature certifies battlefield readiness.
Packaged for global shipment, each launcher is preserved and protected for the journey to military forces who will depend on its reliability.
From this facility flows defensive capability, instruments of precision engineering ready to serve those who defend